Hi dear students, welcome to Maths Unit Rational Numbers. In this class, we shall start the problems from 7.1 with exercise 2.1. Just read it. Tell what property allows you to compute 1 by 3 into 6 into 4 by 3 as 1 by 3 into 6 into 4 by 3. Just take down solution. Just observe the we already know all the properties, isn't it? Just observe it and write this. Which one? This one belongs to which property? As write down 1 by 3 into 6 into 4 by 3 equals 1 by 3 into 6 into 4 by 3, as this is of the form A of B into C equals A into B of C. Therefore, this is associative property. Associative property of multiplication. Once again, this one follows the property to compute this one. It is associative property of multiplication. Now take down 8.1. Is 8 by 9 the multiplicative inverse of minus 1 by 8? Why or why? As solution, just consider minus 1 by 8. It is in mixed fraction. We already know that multiplicative inverse and additive inverse, isn't it? Just simplify this one and convert into improper fraction. Here it is take into and here take plus. Minus into plus, minus 8 ones are 8, minus 8. And here plus 1 is there. Minus 8 plus 1 is minus 7 plus by 8. Minus 7, here it is 8, denominator 8. Minus 7 by 8. And since consider 8 by 9 into minus 7 by 8. If we take any number and product of this reciprocal, then we get 1. Suppose, for example, what is the multiplicative inverse of 1 by 9? Just simple, already know 9 by 1. 9 we cancel 1 by 1, 1. If you consider a number and its reciprocal product, then we get 1. The product of a number and its reciprocal should be 1, then only a reciprocal of that number we call inverse. Yes, here 8 by 9 is there and we consider the product of minus 7 by 8 and 8 by 9. Here 8 ones are 8 ones are 8 get cancelled. And we are remaining minus 7 ones are minus 7, 9 ones are 9. So minus 7 by 9 is the product. It is not equal to 1. It is not equal to 1. So thus minus 1 by 8 is not the multiplicative inverse of 8 by 9. Are you clear? Yes, take it. 9th one is 0.3 the multiplicative inverse of 3 1 by 3. Why or why not? Just simple solution. Consider 0.3. First you have to consider 0.3. Next 0.3 is written in fraction. It can be written as 3 by 10. Our simplified form of 3 by 10 is 0.3. Yes, the multiplicative inverse of 3 by 10. Multiplicative inverse of 3 by 10 is, yes, just we have taken reciprocal 10 by 3. If you multiply these two, 3 get cancelled, 10 get cancelled, we get the product 1. So the multiplicative inverse of 3 by 10 is 10 by 3. 10 by 3 is written in mixed fraction 3, 1 by 3. 3 is a 9, 9 plus 1, 10, 10 by 3. 10 by 3 is of the form 3, 1 by 3. So thus here it is given 3, 1 by 3 as 3, 1 by 3 is the multiplicative inverse of 0.3. It is simple and very easy. Yes, right. Now take down 10th one. Right. Here there are 3 questions. First one, the rational number that does not have a reciprocal. I repeat once again. The rational number that does not have a reciprocal. Answer 0. 0 is the rational number which does not have a reciprocal. 0 is the rational number which does not have a reciprocal. Next, second one, the rational numbers that are equal to their reciprocals. Repeat once again, the rational numbers that are equal to their reciprocals. As answer 1 and minus 1. 1, its reciprocal is 1 by 1, nothing but 1. And reciprocal of minus 1. As reciprocals of minus 1 are the rational numbers which are equal to their reciprocals. You should remember 1 and minus 1 are the rational numbers which are equal to their reciprocals. Next, third one, the rational number that is equal to its negative. Yes, 0 is the number which is both positive and negative. It is equal to both. 0 is the rational number is equal to its negative. Okay, take. Okay, dear students, in this chapter we already learned some properties and some problems. We already worked out some problems based on those properties, isn't it? Yes. On the basis of that, can you answer these? Can you fill the blanks? Yes. I read once again. Next, try yourself. Okay. Yes. Fill in the blanks. First one, 0 has dash reciprocal. Okay, once again, 0 has dash reciprocal. Second one, the numbers dash and dash are their own reciprocals. You should remember, the numbers dash and dash are their own reciprocals. Third one, the reciprocal of minus 5 is, the reciprocal of minus 5 is dash. Fourth one, reciprocal of 1 by x where x is not equal to 0 is reciprocal of 1 by x where x is not equal to 0 is dash. Next, fifth one, the product of two rational number is always, once again, the product of two rational number is always dash. And last one, the reciprocal of a positive rational number is, the reciprocal of a positive rational number is dash. Okay, just try yourself. Okay, dear students, we shall see how many of you have written right answer. Okay, as first one, 0 has no reciprocal. As here in the first you put here right in the fill in the blanks, no. 0 has no reciprocal. Second one, the numbers 1 and minus 1 are their own reciprocals. Third one, the reciprocal of minus 5 is 1 by minus 5. Good. Minus 5 is minus 1 by 5 or 1 by minus 5. Fourth one, reciprocal of 1 by x where x is not equal to 0 is x. Fifth one, the product of two rational number is always rational number. As fourth one, the reciprocal of a positive rational number is positive. Yes, just verify your answer with this, whether you are correct or not. Just correct it. Okay, take it. Okay, dear students, now let us take the heading representation of rational numbers on number line. Already learned how to represent the numbers on number line as in the last classes, in the 7th standard, the 6th standard, etc. Now we represent rational numbers. What are rational numbers? A number can be represented in the form p by q, where q is not equal to 0. First, we just recall the representation of natural numbers, whole numbers and integers. What are natural numbers? Numbers, counting numbers from 1, 2, 3, 4, 5, etc. and so on are the natural numbers. Suppose I take one number line. There is natural numbers from 1, 2, 3, 4, 5, 6. There are natural numbers from 1, isn't it? Here only the numbers indefinitely on the right side of from 1. Right side from 1, isn't it? Here 1, 2, 3, 4, 5, 6 and so on. Here number line extends indefinitely on right side, isn't it? These are the natural numbers. Okay, next, how to represent the whole numbers? Already know the set of whole numbers as the set which contains 0 with natural numbers. This is simple. 1, 2, 3, 4, 5, 6 and so on with 0. The numbers, the 0 with natural numbers. These are the whole numbers. Represent the natural numbers, whole numbers like this. The numbers starting from 0 extends indefinitely on right side the number line. So here 0, 1, 2, 3, 4, 5, 6, 7, 10 and so on. This is the method of representing whole numbers. And integers, a set of integers, a set which contains positive integers means natural numbers, negative numbers as well as 0. Here already number line. Suppose can you represent the integers on number line if someone asks. This is simple. Here already I draw already a number line. Here the positive numbers are there and 0 is there. So negative numbers starting from 0 from the left side of the 0. Here -1, -2, -3, -4 and so on. Here the number line extends on both sides of the 0. Here right side and left side of the 0, in the two way it extends, isn't it? This is the method of representing integers. Now rational numbers, how can we represent rational numbers? Suppose just I take simple example from in between 1 and 2. Can you represent one rational numbers? Just I take here in between, in the middle of 1 and 2. There is 1 and 2 means 1.5. I write it is 3 by 2. Yes, this is the rational number. This is simple. In between 1 and 2 there is the number is 1.5. 1.5 is the fraction 3 by 2. It is a rational number. It is very simple. Dear students, what I gave the information is given in the textbook. Just I read it. Just listen carefully. Okay. Representation of rational numbers on the number line. You have learned to represent natural numbers, whole numbers, integers and rational numbers on a number line. Let us revise them. Already know the definitions of natural numbers, whole numbers, integers and rational numbers, isn't it? First we consider natural numbers. The numbers from 1, 2, 3, 4 and so on are called natural numbers. Here the line drawn and we divide it 1, 2, 3, 4, 5 and so on, and here the line extend infinitely to the right side. Here read it, the line extends indefinitely only to the right side of 1. Here the natural numbers starting from 1 and infinitely to the right side. Whole numbers, here starting number is 0. It includes natural numbers. The line extends indefinitely to the right but from 0. There are no numbers to the left of 0. Dear students, just observe here, left side of 0
there is no numbers, isn't it? Here, right side of 0, natural numbers are there. Whole numbers, it includes 0 with natural numbers, set of whole numbers, isn't it? Next, integers. Already know the definition of integers. Here it includes 0, positive integers, positive numbers, and negative numbers. The line extends indefinitely on both sides. Here observe, in the right side it extended, and in the left side also indefinitely extends. Do you see any numbers between -1 0 and 0 1 etc.? Yes, there are so many numbers are there. So let us see in the next rational numbers. Here 0, 1 by 2, 1, -1 by 2, -1. The line extends indefinitely on both sides, but you can now see numbers between -1 and 0, 0 and 1. Yes, here 1 by 2. 1 by 2 means 0.5. It is the number between 0 and 1. Minus of this means -0.5. It is between -1 and 0. Yes. Okay.
Okay, dear students, now we take exercise 2.2. First one, represent these numbers on the number line. These numbers means rational numbers. Here first one 7 by 4 and second one -5 by 6. Solution. First I take 7 by 4. I already drawn a number line. In that, just I take here, just observe 0 to 1. Only observe 0 to 1. After we discuss about 7 by 4. Okay. 0 to 1 is divided into 4 parts. I see here 4 parts. This is one part. This is second part. This is third part. This is fourth. Yes. 0 to 1. In the scale 0 to 1 is divided into 4 parts. Here means it is 1 by 4 is written as 0.25. 2 by 4 is 2 1s and 2 2s are, it is off means 0.5. 3 by 4 means 0.75. Next 4 by 4, 4 1s are 4, that is 1. Similarly, if we divide 5 by 4, just let us divide 4 1s are 4, divided is 1, a point, 4 2s are 8, remainder 2, 0, 4 5s are 20, 0 remainder. Here it is 1.25. Here also 2 3s are, 2 2s are, 3 by 2 means 1.5, and this can be divided 7 by 4. Divide 7 by 4, 4 1s are, here remainder is 3, take point, 4 7s are 28, remainder is 2, take 0, 4 5s are 20, remainder is 0. 7 by 4 means 1.75. Just observe number line what I wrote here. 0, the numbers on the number line. After 0, 0.25, I take 1 by 4. 0.5, 1 by 2 by 4. 0.75, 3 by 4. 1, 4 by 4. 1.25, 5 by 4. 1.5, 6 by 4. 1.757 by 4. The number is given in the question to represent on the number line. This is 7 by 4. So we just take all the denominator are the 4. Yes, this means 7 by 4 is in the place here. After 1, this is the 1.75. Okay, this is simple, very easy. Just try it. Okay, take it. Dear students, now represent minus 5 by 6 on number line. This is the rational number. I already drawn a number line. It is between 0 to minus 1. As here it is 0, and if we move left side of 0 from minus 1, in between those two, 0 and minus 1, I write some fractions on the basis of the given number. Okay, dear students, here 0 to minus 1, this part is divided into 6 parts. Here denominator given is 6. Okay, here 1, this is one other part, 2, 3, 4, 5, 6. 0 to minus 1, this part is divided into 6 parts. Each point after before 0, from 0 we moving to left side up to minus 1. Here just see here minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. It is simple. Minus 1 by 6, minus 2 by 6, minus 3 by 6, minus 4 by 6, minus 5 by 6, minus 6 by 6 means 6 1 it is minus 1 divided by plus 1 minus 1. Here it is the given number. We represented on number line. This is simple. Here denominator are same, so numbers in the left side of 0 will be same. This is the method of representing a rational number. Right. Dear students, now we take down second one. Represent minus 2 by 11, minus 5 by 11 and minus 9 by 11 on the number line. Just take the solution. I write 3 numbers and already I have taken number line. Here the numbers from 0 to minus 1. In between the 0 and minus 1, I write here the numbers. The numerator is negative numbers and in the denominator it is 11. Isn't it? Here, like previous problems, it is similarly I write and divide the number line from 0 to minus 1, 11 parts. In the previous problem, in the denominator there is 6, so I divide the number line from 0 to minus 1, 6 parts. Here I divide the number line from 0 to minus 1 into 11 parts. Just observe here, 0 to minus 1 by 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. From 0 to up to minus 1, there is 11 parts. Here each part or each point is represented by the number minus 1 by 11, minus 2 by 11, left side of 0, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9, minus 10, minus 11. All the denominators here should be 11. Minus 1 by 11, minus 2 by 11, minus 3 by 11, minus 4 by 11, minus 5 by 11, minus 6 by 11, minus 7 by 11, minus 8 by 11, minus 9 by 11, minus 10 by 11, minus 11 by 11. Minus 11 by 11 means 11 get cancelled. Minus 1 by plus 1, it is minus 1. Okay, we want the numbers minus 2 by 11. Here it is. Yes, minus 2 by 11. This point indicates minus 2 by 11 on the number line. Next, 5 minus 5 by 11, minus 5 by 11. This point indicates minus 5 by 11. Next, minus 9 by 11, minus 9 by 11. This point indicates minus 9 by 11. 3 numbers, 3 rational numbers, minus 2 by 11. This point indicates minus 2 by 11, and here this point on the number line indicates minus 5 by 11. In this number line, this point indicates minus 9 by 11. It is very simple, right? Okay, dear students, in this class we have learned some problems in the exercise and representation of rational numbers on the number line. Okay, try yourself some such type of rational numbers and represent those on number line. And remaining things will be discussed in the next class. Okay, thank you.